Hello guys, in this video I'm going to show how to solve minimum depth of a binary tree. To find the minimum depth of a binary tree, the minimum depth is a number of nodes along the shortest path from the root node to the nearest leaf node. So for example, given this binary tree, as you can see there are six nodes here. Total 6 nodes. What is the minimum depth here? So number of nodes along the shortest path from the root node to the nearest leaf node. So how many paths in total from the root to the leaf node here? So here's one to 2, right? 1 to 3 to 4, right? And 1 to 3 to 5 to 6. There are total 3 paths from root to the leaf, right? But what is the minimum depth, right? What is the smallest number of nodes? What is the path with smallest number of nodes here? So it is 1 to 2. There are total 2 nodes in this path, and it is actually the result going to return here for the minimum depth, right? Which is 1 to 2. It is 2 nodes in total, right? It is a shortest path from the root to the leaf node, right? So uh, for tree problem, we can go with depth first search and breadth first search. But let's think about the efficiency here. Do we really need to go all the way to the do we really need to check all the paths? Do we really need to go all the way to the most to the deepest node here? Like for example, our tree can go all the way down with a depth of 100, for example, but the shortest path is only 2 here, right? So probably if we go with breadth first search, we can stop right away and return the current depth if we when we reach a node that is a leaf node, right? For example, here we're gonna start with the first level, right? We're gonna go level by level. So for each level, we're gonna check if the current level is if any node that is a leaf node, right? So when we find leaf node, we're gonna stop right away, and it should be the nodes, the minimum depth at that level, right? So we're gonna start with level 1 here. So there's only one node in level 1, and which is node 1, but node 1 is not a leaf node. So we're gonna go to level 2, right? For level 2, we're gonna check node by node, right? First with node 2, and we realize that 2 is a leaf node. So we can stop right away. And we know that we are at level 2, so it means the minimum depth here should be 2, right? And we don't need to go down further the tree, right? So that is pretty much it about this problem. We're gonna use breadth search for this problem. For breadth search, I need a queue, right? I need a queue, and initially the queue will, there's one node in the queue which is a root node, right? I'm gonna go as long as there's something in the queue, right? And for one iterations here, for each iterations of this while loop, wanna process one level, right? Wanna process one level, right? So before jumping into process level, we need to know the how many nodes are they in the current level of the tree. So it is actually the level size will be the queue size, right? At the beginning of the loop, the number of nodes in the queue is actually the level size. So I want to process this exact amount of nodes, uh, this exact nodes from this level, right? So as long as the level size is still greater than 0, I want to continue to process this level, and for each iteration here I will process one node from current level, right? And after processing one node from the current level, I will decrement the level size by 1, so that after exceeding this loop, I will process all nodes from the current level. Okay, to process node from current level, it's simply by it's simply by dequeuing, right, from the queue. So node out is equal to queue dot ship, right? So enqueues is push and dequeue is ship, right? We push in one side the queue, and we dequeue from the other side of the queue, right? First in, first out, right? First in, first out. Okay. Oh, by the way, first in, first out is the queue, right? Okay. But how about the stack? The stack should be first in and last out, right? By the way, node out ship here. Okay, the node is out, and I want to check if the node is a leaf node. So is leaf node. It is a leaf node when I don't have a left and I don't have a right. So if it is a leaf node, I want to return right away. What is circle level? I want to return what here. So we need to keep track of a variable which is the let's say the level. So initially it's level 0, level 0, right? So at the beginning of these iterations I will increment level by 1. So okay, so here I can return the current level, right? So for example, here's level 1. We go to next next level is level 2. So 2 is a leaf node here. I will return the current level, which is same as the depth, the current depth, right, of this node, right? So I return here. Otherwise, if it comes here, it's not a leaf node. So it either has left or right, or both left or right. So I want to iterate, right? The child can be one of the left or child, not L left and not L right, right? So it is not guaranteed that child is not empty. So I will need to check only if we have a child that is not empty. Then I'm gonna push the child to the queue. The child will be the node of the next level. Put child here. So okay. I push the child to the queue for the next iterations, right? That will process the next level. Here I will process one node, right? As long as the level size is still greater than 0. Okay, that's fine. And yeah, we will at some point in time get in here, which is the leaf node. I return the current level, which is something that we gonna do as soon as possible, right? But if somehow we exit the loop, is there any case that we will exit the loop here? It is when the queue size is 0 and we still we didn't we haven't reached this line, we haven't jumped into this line yet, so it's something wrong here. So I will throw an arrow here. Something went wrong to kind of like tell the developer that there's something wrong here. Okay, just 7 and 5. Yeah, it should. Yeah, it works. perfect, to make sure that it is actually ran our code. Okay, it works perfectly. So that is it for minimum depth of a binary tree using breadth search, right? Or level audio traversal. So that is it for this problem. Thanks for watching. See you in the next one.